All right, today we're diving into the hidden science behind the color of your clothes. We're going to uncover the chemistry that makes some fabrics pop with these brilliant, lasting colors, while others, well, they just fade away. Let's get into it. Seriously, have you ever looked at, say, a bright blue wool sweater or a deep red silk scarf and just wondered, how? The color feels like it's part of the fabric, you know? It's not magic, though. It's some very specific chemistry, and the star of our show today, it's something called an acid dye. All right, first up, what are acid dyes? Let's talk about this secret ingredient for color. Okay, so here's the deal. At its heart, an acid dye is basically a type of salt. And the name acid dye? It's a little tricky because it's not that the dye itself is an acid. Not at all. It's all about the process. See, to make that color stick, you have to use it in an acidic solution, what dyers call a dye bath. And that acid, that's the key that unlocks the entire reaction. You know, acid dyes are actually pretty picky. First off, they dissolve in water, which is how you make the dye bath in the first place. But the really crucial part is who they choose to hang out with. They form these super strong bonds with protein fibers. We're talking wool, silk, and also synthetics like nylon. But they totally ignore plant-based fibers like cotton. And this choosiness, that's the real secret to how they work. Okay, let's get into the chemistry of it all. How does that color actually get from the water and lock onto the fiber for good? Well, it all comes down to what I like to call a molecular handshake. It really is all about attraction. Just picture the surface of a single wool fiber. It's like this microscopic landscape, and it's covered in these tiny little docking stations. The dye molecule, that's our ship, and it's looking for a place to park permanently. But for this to happen, everything has to be just right. So here's how that molecular handshake goes down, in just 3 steps. First, you've got your protein fibers, like wool. They're covered in something called amino groups. Think of these as our docking stations. Step 2, we add acid to the dye bath. This activates those docking stations, giving them a strong positive charge. And finally, step 3, the dye molecule itself is negatively charged. And you know what they say about opposites? They attract. The dye just snaps right into place, forming this incredibly powerful ionic bond. And boom, that's the handshake. The color is now chemically locked onto the fabric. It's not going anywhere. Okay, so it's not like there's just one type of acid dye. This is actually a big, diverse family of chemicals, and there are a couple of different ways to group them. So one way you can sort them is by their actual chemical structure. You've got anthraquinone dyes, which give you those great blues and greens, and then you have monoazo dyes, which are awesome for reds and yellows. I mean, just look at them. Their structures are totally different. And that underlying chemistry is what determines their color and how they perform. But, you know, for the people actually using these dyes, there's a much more practical way to think about them. Yeah, dyers came up with a system that's way more hands-on. They group them based on how they actually behave in the dye bath and the kind of results you get. And honestly, this is where it gets super useful. This table breaks it all down into the 3 main families. So on one end, you've got strong acid dyes. These guys need a super acidic bath, but they give you this fantastic leveling. That's a perfectly smooth, even color. The catch? They're not the best when it comes to washing, what we call wet fastness. Then, all the way on the other end, you have neutral acid dyes. These create an incredibly durable color, awesome wet fastness, but because their molecules like to clump together, they don't spread out quite as evenly. And the weak acid dyes? Well, they're kind of the happy medium. So it's always a trade-off, right? Do you want that perfectly even color, or do you need something that's going to survive a lifetime of washing? All right, enough theory. Let's see how this all plays out in the real world. We're going to walk through the actual step-by-step recipe for dyeing wool. And we're going to use the one we just talked about, the strong acid dye. Why? Because it's a perfect example of just how precise this whole process has to be to get that beautiful, even color. Okay, here's our ingredient list, and all the percentages are based on the weight of the fabric. First, the dye stuff. That's our color, obviously. Then, sulfuric acid. That's to get the bath to that low pH we need. And then we have Glauber salt. Now, this stuff is absolutely crucial. It's what's called a leveling agent. It basically tells the dye to slow down, take it easy, which prevents it from rushing onto the fiber all at once and making splotches. It's the secret to getting that perfectly even finish. This graph shows you just how controlled this whole journey is. We start the bath at a moderate temperature, right? We add the wool, the dye, the acid. Then we slowly bring the heat up to 60 degrees Celsius. And here we pause. We hold it there for about 10–15 minutes and add our salt. This pause is so important. It gives the dye time to spread out evenly all over the fiber before it starts to lock in. Only after that do we crank the heat up to a full boil and hold it for about 45 minutes. That final blast of heat is what gives the molecules the energy they need to form that permanent bond. So you see how it all connects. Every single step in this process is tailored for this specific dye. The low pH from the acid gets those docking sites ready, while the salt and that slow, careful temperature increase make sure that molecular handshake happens evenly all over the fabric. And that's how you get that flawless, level color. So after all that careful chemistry, you get the final, vibrant result. But you gotta remember, the success of this whole thing depends on starting with the right fabric in the first place. And this is really the key takeaway. Acid dyes work their magic on protein fibers like wool and silk and synthetics like nylon because those fibers have the docking sites we've been talking about. But plant-based fibers, cotton, linen, rayon, their chemical structure is completely different. They just don't have those docking sites. The dye literally has nowhere to park, so it just washes right out. It's pretty amazing when you think about it. The whole journey starts with a simple salt that dissolves in water. But by understanding the chemistry, by controlling the pH, the temperature, the special ingredients, we can turn that simple salt into a permanent, vibrant part of the clothes we wear every day. So next time you pull on a colorful sweater, just take a second. Remember that intricate molecular dance that had to happen to create that color. It's not just sitting on the fabric, it's chemically bonded to it. It's just a great reminder that there's all this hidden science woven into every part of our world. Makes you wonder, what else are we missing? Thanks for joining me.